Have you ever heard of this thing called Terraform and wondered what it is? Maybe you've heard of Terraform Cloud and wonder how the two relate to each other. Well, don't worry, we're not talking anything about science fiction here today. There's no transforming planets in the picture for this one. We'll be talking all about Terraform, which is an infrastructure as code framework that you can use to deploy your workloads to Azure. Listen in as we find out more. Hello there and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and here we talk about all things cloud. Now, thanks for joining in. You know what to do if you like this content. Please go ahead, like the episode, subscribe to the channel and hit that notification bell so that you know as soon as there's more content available for you to watch or listen. Because of course, we're not just on YouTube, we are also on Spotify, Apple Podcasts and Google Podcasts, as well as cloudwithchris.com. So thank you for the support, and with that, let's waste no time. Let's jump straight in to this episode. So, we mentioned there that we're going to be talking all about Terraform. So what I'm going to do here is I'm going to switch over to my screen and we're going to talk all about Terraform. So, what is Terraform? Well, as I mentioned earlier, Terraform is this open sourced infrastructure as a code software tool. So, given that it's open sourced, it's something which is available for a number of different areas, a number of different providers, and we'll come back to those in a minute. But ultimately, there's this idea that you'll write your code declaratively, so rather than saying how you want it to be created, you say what you want to be created. And then Terraform on the back end just deals with the how. So it will map back in reality to, from an Azure perspective, for example, the back-end Azure APIs. It will figure out the changes that it needs to do to get your environment in line with a particular configuration that you've set there. Now, you write the code using any editor of your choice. It's written in a language called HCL, or HashiCorp configuration language. And it's a really nice language, actually. I guess if anyone's ever used ARM templates, you'll be familiar with how verbose that these JSON templates can be. Terraform and HashiCorp language in particular, or HashiCorp configuration language, I should say, is very nice and concise in that sense. And from looking at Bicep so far, it looks like there's some similarities between the two languages there as well. Not exactly the same, but definitely some similarities there. Now, when you're actually going ahead and running your Terraform scripts, deploying them, for example, what you do is you have two different stages. You have this thing called a Terraform plan and a Terraform apply. So the plan step is going to tell you what's changed. So what is being added in your infrastructure, what's being deleted, what's being changed. You can review that, and once you're happy, you go ahead, run the Terraform apply, and it lets loose on your environment and it goes ahead and deals with that. Now, one of the things, though, about Terraform in particular that is different to, say, something like Azure Resource Manager and ARM templates, if you've used those before, is how you deal with the state itself. So Terraform, you have to go ahead and manage the state yourself. So it's not like you can use the Azure Resource Manager model where the state is actually persisted in the Azure backend. It knows, the current state of the resources, makes the necessary changes. You have to maintain a state file somewhere for your Terraform deployments. Why is that important? Well, those state files will also have, of course, potentially passwords inside of them. So you need to make sure that you're storing those particular state files in a secure way, and actually in a way that you're not going to, potentially lock yourself out from making changes. So making sure that one person makes changes at a time, you don't get this kind of deadlock of multiple people trying to make changes on the same environment, for example. Now, one way that I've seen a lot of people do this in the Azure space is hosting the state in an Azure storage account. Inside of Terraform, you have this concept of a remote state provider. By default, when you use Terraform, it will persist the state on the local machine that you're running it to, unless you have this thing called a remote state provider set up and configured. But what you can do with Azure is you can go ahead and set up a storage account as your remote storage provider, your remote state provider there, which is great, works well. But the challenge with it for me is that's an extra overhead that I have to go and manage in my environment. Now, don't get me wrong, I absolutely love Terraform. I think it's a brilliant tool, but that's one of the things that sometimes can be a bit challenging for different organizations starting to take their journey to using something like Terraform. So what we're going to do is we're going to talk about Terraform Cloud and how it can help you with some of those challenges and some of those problems there. Before we do that, let's jump into Terraform and just take a look at a few different things here. So I mentioned a moment ago that Terraform is this open source provider, open source framework, and there are a number of providers for Terraform. Now, what it doesn't mean is that you write your code once and you can deploy it anywhere. This is a bit of a misconception, I think, sometimes with Terraform. But what it allows you to do is use a standardized configuration language to go ahead and point to many different platforms. So as you can see on the screen here, we've got this provider documentation, which has recently changed. A lot of that is now hosted on the Terraform registry. So you can see that on the screen now. I've just navigated across to this registry. And of course, there's things like AWS, Azure, GCP. There's one even for Kubernetes, Oracle Cloud, Alibaba Cloud, Active Directory, Azure AD, Azure Stack, for example. There's even some for HashiCorp Cloud itself and HashiCorp Enterprise if you use that. But really the point I'm trying to get to here is the fact that there's a number of these different providers that you can plug in to your Terraform configuration that you can then use in your infrastructure as code. But it's not you write it once and can deploy it anywhere. You would have to write a deployment for AWS, a deployment for Azure, a deployment for GCP if you wanted to deploy across all clouds there. So as an example, let's go ahead and take a look at the Azure RM provider here. Now, you can see that on the top of the page here, or some of the first things that we see, are these top downloaded modules. And these are modules which have been built by the community, potentially by Azure in some cases here, or people in the Azure community at least, for example, relating to the cloud adoption framework pieces here. These are a number of pre-packaged modules that you might go and want to use, but sometimes there may not be modules that exist for the stuff that you want to go and do. This is where you can go ahead and jump into the Azure RM documentation, and there's a huge list of all of the different resources that are supported in the Azure RM provider. Now, it's a good list. It's a growing list. It's not necessarily going to be 100% parity with ARM. That's one of the other things that I commonly see people stumbling into. So if there's something that's not quite there yet, your best bet is to look at the Azure RM repository on GitHub and raise a GitHub issue there, because the team review that very regularly to go and take a look at what is, blocking people from deploying using Terraform. Now, as we just scroll down here, you can see we've got this example of a Terraform file here. Quite a nice syntax, quite easy to understand there. I'm not going to go into the nuts and bolts of how Terraform necessarily works here and the syntax and all of this, because there's plenty of material out there. What I'm going to do is I'm going to be focusing on Terraform Cloud and deploying to Azure. So as an example here, this particular example loads the Azure RM provider for us, so downloads the necessary pieces when we run that particular Terraform apply, Terraform plan. And then what it allows us to do is use these Azure RM resources, these Azure RM provider. So we're creating a resource group called example-resources, and then we've got this example-network, which is a virtual network, and then it's going to be in this particular resource group, the same location as the resource group, and then it's going to have this address space. That's what that example is showing us. Nice and simple and easy to understand. Now what we can do is we can go ahead, take a look through any of these different resources on the left-hand side, how we go and create these networks or resources, and how we can go and reference existing resources that have been already made as well. And they're using data sources. So you have these two types here. You have data sources and you have resources. Resources is creating something brand new for us and provisioning that, checking that it's there potentially. I guess potentially dealing with the configuration drift as well, if there is any configuration drift. Whereas the data source is all about pulling information in from existing sources that may be elsewhere, for example. So that's the whole idea behind these providers. So let's move on now and start thinking about this thing called Terraform Cloud. Terraform Cloud is a platform that allows you to run this kind of pipeline of work. So this Terraform plan, this Terraform apply. Now, I'm just going to jump across here to the pricing page just for a moment, just so you can see the difference, because I think this will help you understand some of the differences between something like Terraform Enterprise and Terraform Cloud. So Terraform Cloud, the hosted version by HashiCorp. Terraform Enterprise, your self-hosted version. And for what I'm going to show you, I'm using the free version of Terraform Cloud. And effectively what it allows me to do is just go ahead and have effectively a CI/CD pipeline for my Terraform environment, but it gives me a lot more than that. It also gives me the ability to manage state, to manage variables and secrets, a number of different other things in there as well. But if you're an organization that cares about policies, managing your team, compliance, single sign-on, all these things, that's probably not going to be right for you, and you'll need to go and take a look at the different Terraform Cloud options there that are appropriate for you. But that is the difference between these options. So there's no better way for us to look at actually running Terraform Cloud here and actually taking a look at it, I think, than trying to describe it here. So you can see on the screen now that we're running a browser here, which is showing my Terraform Cloud instance. And I've got three organizations, one for Cloud with Chris, one for a pet project called Theateers that I started at one point, and one for Yu-Gi-Oh cards, which I've mentioned on the channel a few times here. So I'm just going to jump into this Cloud with Chris organization here. And what you can see is I've got two workspaces. And a workspace is effectively like a pipeline. It also gets bundled with a few other things. So let's go ahead and just take a look at Cloud with Chris Core for a moment and see what's going on in here. So as you can see, there's this similar kind of experience to what you would get with like GitHub Actions workflows, or what you would get with Azure pipelines and GitLab's pipelines, for example. You get this list of runs that have happened in the past. And you can see here they're connected to some kind of repository with some kind of commit as well. We'll come back to that in a moment. But then what I can also do is I can also click on this states option on this tab at the top here. And I can click on that. What it will do is it will show me that state file for that deployment. So I can see what the existing state file is. Now, the last command that I ran was a Terraform destroy. Hence, you see it all showing in red here because it's removed all of the state from that state file. But this is what I was referring to earlier. If you don't use something which is managed like this Terraform Cloud option, you would have to go and manage these state files in something like a storage account or in something like Console or some other provider that can be hooked into from that perspective. So that's an extra bit of overhead that you would have compared with using something like an ARM template, because ARM deals with that state inside of the servers itself. That's the difference between ARM and Terraform. ARM is a service, Terraform is a framework that you can go ahead and use across many different providers. So what else do we have in this particular workspace? We also have some environment variables. I didn't show it in the documentation earlier, but the Azure RM provider, the way it works, or one of the way it works at least, that you can authenticate to Azure, is by using these environment variables. So an ARM tenant ID, an ARM client ID, ARM client secrets, and an ARM subscription ID. And that is how then Terraform can authenticate by using a service principal to get access to my subscription and make the necessary changes there. So let's go ahead and take a look at some of the settings here. What I'm going to do is I'm just going to go ahead and jump down to version control. And what I'm going to do is show you that actually this is connected up to my GitHub repository. So I've mentioned my cloudwithchris.com repository a few times in the past already. This is what it's connected to. So anytime that there is a commit in that particular repository, and it's in this particular path of my Terraform folder /environment/core, because we're looking at my kind of core unit of deployment now, for example, my core services rather than a specific stamp, then trigger this pipeline to go and run. So it's exactly like we would see with something like GitHub Action Workflows, Azure Pipelines, GitLabs Pipelines, etc. This kind of CI/CD experience. Now we can also go ahead and, of course, go and queue that manually. So if I go ahead and click on queue plan here, what it will do is it will start running that plan step for us. So it gives us the ability to understand what has changed, review it, make some comments before we want to go and progress. So maybe it all looks good and it's all fine, or maybe we need to make some tweaks. So you can see there that that plan is now running. I can actually look at the live output here and I can see, okay, so it's creating a CDN profile here, core profile. It's going to be created in North Europe. It's going to be called this name. It's going to be in this resource group. Okay, cool. And it's going to create that resource group for me as well. Okay, looks great. So let me go confirm and apply. We'll go and confirm that. And now what it will do is it will go ahead and run that for us in our environment. Now I might have some challenges here because I've just realized I think I created a environment with Project Bicep actually already, so we might get some conflicts here. So if we do, I'll just need to go and rerun that. One of the other things that you can do is import existing states into a Terraform state file as well. So if you've already deployed something, but what I would recommend is taking a look through the documentation before you decide to go down that path, because it is quite involved in terms of arriving at that particular situation there. But let's jump across now to the GitHub page for just a moment here. So you can see in my GitHub repository, I've got this Terraform folder here. If I just click into that and click on environments first, I'm going to look in this core folder because we were just deploying this core set of resources. And you can see here that we've got a number of different pieces. We're importing the Azure RM provider version 2.46. So that's a certain API version effectively, or provider version. We're calling and saying we want to bring in that Azure RM provider there. And then what we're doing is we're saying that we want to deploy a module. Now, a module inside of Terraform is a nice, easy way to group together a unit of deployment effectively and easily manage kind of different components, different life cycles of code and infrastructure that we might deploy. So you can see that we're referencing that modules folder, which was a couple of directories up there. And what we're doing is we're passing in a number of different variables. Now, don't get confused if you're coming from the ARM world here. We're not talking variables like you would in a software perspective. We're talking more like a parameter, something that could be changed at deployment time to affect the kind of resulting infrastructure or resulting template. So passing one in for the resource prefix there, CWC-core, North Europe is location, and then a series of tags to be injected as my resource tags there. So if we go a couple of levels up, go to modules and go to core, now we can see, for example, that we've got this variable resource prefix. So we're saying we accept this particular variable. Again, it's more like a parameter if you're coming from the ARM template world. Location and tags there as well. And what we're doing is we're going ahead, creating a resource group in that location with those tags and doing the same thing with a CDN profile as well. Similar idea really here on the stamp side of things. So what I've done is I've got this stamp concept as well. So the stamp being, I might have a dev, I might have a QA, I might have a prod, maybe it'll be in North Europe, West Europe, etc., etc. And you can see that all this is doing is creating a storage account for us here, and also an endpoint on that central CDN profile. Couple of interesting things going on here. First off, I've got these variables again, so like parameters, and we've got this thing called a local. Now, a local is what a variable is inside of ARM templates. I know it's a little confusing that you've got variables and locals and parameters, these different terms, but imagine if you're in the ARM template world, a parameter is a variable in Terraform, and a variable in ARM templates is a local in Terraform. So what we're doing is we're going to create our stamp resource group. So that would be like a dev, a QA, a prod resource group. And then we're just going to pull in that data source for that central CDN profile. So remember that I mentioned earlier, you have resources and you have data sources. So this is an example of pulling in that central data source. We don't need to check it's there or create it or update it and maintain it as part of this particular life cycle. We just need to reference it. So we assume that it's already there. So we're specifying, that core CDN resource in that core resource group. Then what we're doing is we're deploying a storage account. We're going to do some wizardry here to remove the dashes, as you saw a little bit further up in this template. And then we're just going to deploy the static website kind of configuration here. And what we're going to do is we're going to use that data source for the CDN profile that we used a bit earlier and create this endpoint here. So this endpoint then goes ahead, creates a CDN endpoint on the CDN profile for us. It goes ahead, pulls in the primary web endpoint from our storage account, removes some of the pieces to make sure it's a valid domain name, then goes ahead and creates that for us. So you can see how easy it was to kind of bring that all together. Quite a few lines of code, actually, not that many. If we were comparing it with a full ARM template, for example. So really nice and understandable, I think. That's the thing that I really like about these Terraform templates. So there we go. That's that Terraform did actually run. So I suspect that it was indeed this one that run. No. So I actually called it something different. There we go. This one in Bicep, I have a -rg as a prefix, whereas in the Terraform world, I don't. So there we go. We're all good there. So you can see, for example, it created the resource group for us. It's created the CDN profile, but no endpoints are created as yet. So now let's go ahead and create this dev environment for us now. So once again, what's going to happen is we're going to go ahead and run that plan. We'll get the chance to validate, is that as we'd expect? Is it creating or changing or deleting the resources as we would expect them to? And it will go ahead and, of course, persist the state to that Terraform Enterprise workspace or Terraform Cloud workspace for us there. So as we can see here, it's going to go ahead, create this storage account with quite a few more settings than what we actually set there. And it's going to go ahead and create that resource group and that CDN profile for us as well. But again, all looks good to me. And let's just double check. That resource group is going to be CWC-dev. No RG on the end there. So we're all good. So let's confirm that plan. So while we're waiting for that to go ahead, let's just jump back to core and show you that states section again. Now this is what I was saying here, that you can actually see all of these kind of sensitive information here. So if I had, I don't know, let's say I'm using the Azure AD resource provider and I have provisioned a service principal, for example, which is actually what I did in my Yu-Gi-Oh cards example. What I did in the Yu-Gi-Oh card scenario was I had one central core pipeline. I'm going to call it a pipeline. I guess it's a workspace, really. And what that did was that created for all of my different microservices the Terraform Cloud workspace, a service principal with appropriate permissions for that particular workspace as well, and put all of that into my Terraform workspace, all the settings that are needed, the client IDs, the client secrets, all of that stuff, and completely bootstrap the environment for me. You can even do that with something like the GitHub repository secrets as well. You can provision those using Terraform as well. So if you think about it, this can actually be really, really powerful, because you can go for this very low touch provisioning model to set up this entire environment, including the necessary service principals, etc., to go ahead and actually provision those other workspaces then, right? So it's a really interesting kind of use case. But the challenge, though, coming back to the main point, if I've got something like an Azure AD provider that I'm using, and I've provisioned my service principal, my account, my passwords, etc., 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 those passwords, those secrets will be in plain text in this particular state file. So you need to make sure that that state file is being held securely and safely, and the access is being restricted to that, because you don't want anyone to be able to access that, because if there's a breach, if there's a challenge, or if they just think they're doing the right thing and they do something wrong, they potentially leak that, there's a problem there, right? So be very careful with how you manage those state files there. And it looks like we have had a problem provisioning here. Let's see what's going on. So error creating storage account. So the storage account named CWC dev already exists under the subscription, so I knew we'd get a failure at some point. That is no problem. What I'm going to do is I'm just going to go ahead and delete that existing storage account for now. And then we'll rerun that just to show that working here again. Good. So let's go and queue that plan once again here. And then what we'll see is this time, all being well, should all succeed without any challenges for us here. There may be one challenge with the CDN profile actually on the other, or rather the CDN endpoint on the other CDN profile. So I'm just going to go ahead and remove that for a moment, just in case. There we go. So that one's now being removed. And of course, in a real world environment, you'd have a better kind of deployment scenario, better naming structure, etc. But this is just to quickly showcase the examples, because I will be doing a similar setup using Bicep as well, coming very soon. But you can see here, once again, as we expect, the plan finished, everything was successful there. We can see that CWC dev has now deleted from the other profile. So let's go ahead now and apply this particular plan to work here. Now, the way that you can go ahead and create a new workspace is super easy. You have these different types of workflows. You've got a version control workflow, a CLI-driven workflow, an API-driven workflow. I think for most cases, CI/CD is probably what you're going to be looking at. So attaching to a version control system there. So then you go ahead and hit something like GitHub. And you can see there I've actually set up using OAuth, so I've only granted access to that one particular repository there, rather than other repositories that I have access to. So that's as simple as it is to go ahead and create one of those workspaces. You then go ahead, configure your environment variables, your Terraform variables as needed. So these Terraform variables are those variables, or in ARM speak, those parameters that we mentioned a bit earlier. So if we want to override some of those defaults that are in place, for example. And if we jump back, what we'll be able to see is that the storage account has created, the CDN endpoint is still creating there. So if we just navigate to the resource group, we should be able to see, of course, this was the Bicep version. If we refresh, we can go and see now in this resource group, we have the CWC dev. If we go to our CWC core, we can now see that we've got the CWC dev CDN profile there as well. So that just showcases the difference between something like GitHub Actions, Azure pipelines, GitLab pipelines, etc. How you can go ahead and use Terraform Cloud for your CI/CD for your Terraform workloads, not having to deal with the extra complexity and the overhead of using your own kind of state provider, for example, and hosting that in an Azure storage account. You could just go ahead and use that in Terraform Cloud, for example. So that's as much as I really wanted to show today. Let's jump back away from the screen. So thank you for tuning in. Hopefully that was useful and a bit of an insight into Terraform, what it is and how it relates to Terraform Cloud, and how you can go and use that in your own Azure environments. So you know what to do. Please go ahead, like that episode, hit the notification bell and hit subscribe as well, so you know as soon as there's new content, and please spread the word. I am doing this for you. I am doing this for the community. I love making this content for you, and I want to make sure that I'm making the content that is right for all of you. So if you've got any ideas, any suggestions, just get in touch with me on Twitter at RedOBowen, or feel free to contact me via Sessionize if you're a speaker and you want to get in touch and you want to be a guest on the show as well. More than happy for that. Would love to have you on. So as a reminder, not just on YouTube, also on Apple Podcasts, Google Podcasts, Spotify, and of course cloudwithchris.com. So thank you for watching. If this has been interesting, let me know. We can do much more on Terraform, and I am planning to do some cloud drops around this as well. Very succinct, very focused content on each of these different areas. So again, if you're focused on a particular area, let me know, because I can make sure I prioritize that for you. So thank you for listening. Stay safe, stay healthy, and until next time, bye for now.